All right, let's try the second problem. It says use the graph to answer the question. Let's go ahead and assume that these are arrows right here. Whoops, that's actually, we can tell that that's not an arrow. So let's call this an arrow here, but let's call that a dot, and it looks like it's a solid dot right there. So that point right there is -5, 0. Let's just write it in so we have it. That point right there, it already tells us is 2, -1. There's 0, 1. Here's -2, 3. All right, great. So the domain, what's the domain? Well, it goes from -5. Remember, they're asking for on the x value, it goes from -5 all the way to infinity. So that's correct. Good job. -5 inclusive, all the way to infinity. So you put a bracket around it. So again, I'll write it down here. The domain is from -5 to infinity. What's the range? Well, it's not, if I draw horizontal lines down here, it doesn't touch the graph. It doesn't start touching the graph until this point, which is -3. That's the y value. And it keeps touching it all the way to infinity. So the range is -3 to infinity. The student that did this did it correctly. The intervals, where are the increasing and decreasing intervals? I'm going to do this a little bit quicker this time. So the intervals of increasing and decreasing, what that means as you go from left to right, is the graph going down? If it is, it's decreasing. So it's decreasing from here to here, and then again from here to there. Because from left to right, the graph is going down. So let's see if they did this right. Decreasing intervals would be from -5 to -2. Good. And then you would say union, probably. Union from 0 to 2. Good job. That is done correctly. Increasing intervals would be the other ones. It would be from -2 all the way to 0, and then from +2 to infinity. -2 to 0, +2 to infinity. Good job. Put a U in between there. Great. Let's look at the max and the mins. So if I'm looking for maxes and mins, and really they mean also relative max and relative min. So there is no maximum. There is an absolute minimum right here. So the absolute minimum is at -3. That's an absolute minimum, meaning it's the minimum of the entire graph. It never gets lower than that. So your minimum could be -3, but there's another minimum. There's a relative minimum right here at -1. Because that point right there, I could draw an open interval around this point somewhere on the x-axis, and there is a point that is definitely the smallest point inside that open interval. That's how you know it's a relative minimum. So that's a relative minimum. A maximum, there's a relative maximum at 1, not at 0. So that's wrong. There's a relative, and it's a relative maximum. There is no absolute maximum, but there's a relative maximum of relative max of 1 at 0. 0 is not the relative maximum. The relative maximum is 1, and it's at the point 0. So you could say 0, 1 is your relative maximum. Probably get away with that. This point right here is, some books teach that could be called a relative max as well. Some books don't. So you might be able to say that there's a relative max. Actually, no, I don't think you can. Because you can't draw, remember, you have to be able to draw an open interval around it. And you can't. That would just be called an endpoint, which is still a nice point to have. It's a critical point if you're for some applications of math that you're doing, but it's technically not a relative maximum. Continuity. This is continuous from -5 to infinity, because you never have to take your pencil off the graph and you can draw the entire thing. There's no jumps, there's no holes anywhere, and like we said, we're assuming that it goes forever. Concave up. It is concave up from, this is a little bit tricky. I'd say it's concave up from -5 to, no, I would not say that. this would not be considered concave up right here because of that point. It's a little bit too complicated to get into, but that's more of a calculus thing. It is concave down from here to here. It's concave down, and then again right here there's an inflection point, and then it turns concave up from there to there. So I don't know, you might want to check your book at how they want you to do this, but from my experience, you'd say it's concave down, or you'd say it's concave up from, you can just randomly pick a point here. There's actually a calculus way of doing it, from negative or from positive 1 to infinity, and it's concave down from, let's say, -2 to +1, right in that area right there. It's concave down. End behavior, as x approaches infinity, the graph keeps getting higher, so it approaches infinity, and does not exist again on the end because there's a dot there, not an arrow, so it's going to stop. Hope that helped.